Hey everybody. So we've been adding, subtracting, and multiplying polynomials. Now we're going to dive into factoring these guys. So just as a quick review, we've seen all of these polynomials before. The first one being a general trinomial. So a trinomial here is the sum of 1, 2, 3 monomials. And to factor this, all we're doing is identifying factors of 2 and factors of 20 that have a difference of 3. And once we factor this guy down, we get 2x plus 5 times x minus 4. Another version of a trinomial here is the perfect square trinomial, which we've seen when we worked with completing the square. So for this guy here, x squared plus 8x plus 16. X squared is a perfect square and 16 is a perfect square, so we can break this down into x plus 4 all squared. Another one we've seen is the difference of two squares. Here we have 9x squared minus 1. 9x squared here is a perfect square, and 1 is also a perfect square, so if we take the square root of both of those, the square root of 9x squared gives us the 3x, and the square root of 1 gives us the 1. And we have a plus and minus here, so that means our middle term is going to disappear. And the last here is the common monomial factor. This refers to Mr. Breckland's #1 rule of factoring. Always factor out a common monomial first if you can. So 8x squared plus 20x. Both of these monomials have a 4x in common, and once we factor that out, we're left with 4x times 2x plus 5. So the key concept down here for factoring polynomials is just to make sure that the polynomial is factored completely. And that means it is written as a product of unfactorable polynomials with integer coefficients. So if we look at the examples here, 2 times x plus 1 times x minus 4, we can't break that down any further because x plus 1 and x plus 4 are factored down completely. And for the second here, 5x squared times x squared minus 3, that's also factored completely because we cannot factor x squared minus 3 into a simpler form. So an example of something that is not factored completely would be 3x times x squared minus 4. We can factor x squared minus 4 down to x plus 2, x minus 2, and that is an example of a difference of two squares, x squared minus 4, which we saw right up here. Give these three problems a try quick, and we'll run through them one by one. The main thing to do here is to factor out a common monomial first, and then try to identify if you can factor down what's inside the parentheses any further afterwards. Press pause and give them a shot. So here's the initial setup for you guys. This is what these three polynomials look like with a common monomial factored out. So let's start with A here. This has a common monomial of x, so once we factor out the x, we're left with x squared plus 2x minus 15. Now we can factor what's inside the parentheses here. We need factors of 1, which is the coefficient of our x squared term, and factors of 15 that have a difference of 2. So let's write this in a simpler form. The x still stays out front. Then let's make two sets of parentheses because we need to factor what's inside the parentheses right over here. So we have a minus sign on the 15 here, and we have a plus sign on the 2x there. So our signs here are going to be plus and minus. To get the x squared, we need an x in the front here and an x in the front there. And our 2 is positive, so factors of 15 that have a difference of 2 are 5 and 3. So our 5 is going to be positive, and our 3 is going to be negative. And that is factored completely. For B here, we have a common monomial of 2y to the third power. Once we factor that out, we're left with y squared minus 9. And y squared minus 9 is a difference of two squares. Y squared is a perfect square, and 9 is a perfect square. And there's no middle term right in the middle here. So we can rewrite this as 2y to the third power. We get two sets of parentheses here because we're factoring y squared minus 9 down. And the square root of y squared is just y. That leaves y in front. The square root of 9 is 3. That leaves us the 3 on the opposite end. And because we have a negative sign in the middle here and no middle term, this is going to be a plus and minus, so our middle term cancels out. And again, this is as factored down as this one gets. For the last one, C here, our common monomial is 4z squared. Once we factor that out, we're left with z squared minus 4z plus 4. And this in the parentheses is a perfect square trinomial. So once we factor that down, the 4z squared stays on the outside. Let's set up our parentheses. And since this is a perfect square trinomial, we're going to have the same thing squared. So we're going to have a z in the front, a z in the front. Our 4 here is positive, but our 4 in the middle here is negative. So to get to positive 4 with a negative sign in the middle, we need a negative 2 and a negative 2. So this can also be rewritten as 4z squared times z minus 2 raised to the second power. So now that we've reviewed factoring a little bit, we're going to dive into factoring cubic polynomials. So this means our leading coefficient now, instead of x squared, is going to be x cubed, or in this case a cubed, for the purpose of this formula. So these two formulas here, the sum of two cubes and the difference of two cubes, are worth memorizing. So I would take a second and copy these two formulas down, and then we will put them to practice. Press pause and copy them down. So the goal here when factoring the sum or difference of two cubes is first to identify perfect cubes. And a good way to do this is to know your perfect cubes. This is something you guys should memorize so you're more familiar with what perfect cubes look like, the same way you know what perfect squares look like. So if we look at the sum of two cubes here, we have a to the third power plus b to the third power. So in the example, we have 8x cubed plus 27. What we need to do is take each individual term and break it down into something raised to the third power. So if we start with the 8x cubed, the x cubed is already raised to the third power, but what number raised to the third power gives us 8? In this case, it's 2x. 2x raised to the third power will get us back to 8x cubed. So 8 is considered a perfect cube because 2 raised to the third power gets us the 8. So for 27 here, what number raised to the third power gets us 27? That's 3. 27 is a perfect cube, and factor down 3 cubed gets us to 27. So once we've identified our a and b here, in this case it's 2x and 3, we can go ahead and substitute those values in to the equation a plus b times a squared minus ab plus b squared. So let's identify our values here. Our a value we've determined is 2x, and our b value we've determined is 3. Now note the formula for the sum of two cubes here. We have a plus b, so for the sum of two cubes, a raised to the third power plus b raised to the third power. That equals a plus b, so the plus matches the plus. And in the second set of parentheses here, we have a squared minus ab plus b squared. So note that the middle term here has a negative in front of it. It's very important not to miss that negative sign. So everything is pluses in between except for this middle term right here gets a minus ab. So we have our 2x for a, we have our 3 for b, and once we substitute everything in, we should get the equation right over here, and this is in simplified form. So the 2x is where our a goes, the 3 is where our b goes, and the first monomial inside the parentheses here would be a squared, so if we square 2x we get 4x squared. For the second term here, a times b would be 3 times 2x, gets us a negative 6x, and then b squared would be 3 times 3, gives us the 9 at the end here. Now for the difference of two cubes, essentially we have the same formula, but our signs change a little bit here. So we have a cubed minus b cubed is going to equal a minus b. Note that the minus is inside the first binomial this time. And in our second set of parentheses, we have a squared plus ab plus b squared. So everything in the second term here is all positive, and our minus sign is going to be in the first term here. So let's take a look at the example. We have 64x cubed. What number raised to the third power gets us 64? In this case, it is 4. So 4x raised to the third power would equal 64x cubed. And what number raised to the third power gets us 1? That's just 1. So 1 raised to the third power gets us back to the 1 here. Now, since this is a difference, first let's go ahead and identify our values. We have a equal to 4x and b equal to 1. And again, we're just going to go right ahead and substitute those two values in wherever we see a and b in this formula here. So a equals 4x, that's our first term in the first set of parentheses right here. Minus b, which is now 1, so we get 4x minus 1 for the first term. And in the second set of parentheses here, we have our a squared value would be 4x squared, gets us 16x squared. A times b is 4x times 1, which gets us the 4x here. And b squared, b is 1, gets us the 1 right at the end here. So we'll work through a couple of these so you guys can practice, but make sure you have these formulas handy while practicing these problems until you get used to the mechanics. Okay, let's take a look at a here. We have x cubed plus 64. Now, the plus designates that this is a sum, and we have two perfect cubes. The coefficient of x cubed here is 1, and 64 is a perfect cube because 4 raised to the third power is 64. So first let's identify what formula we're using. Because it's a sum, we're going to do a plus b times a squared minus a times b plus b squared. Now, once we identify a and b, what number raised to the third power gets us 1? It's just 1. So our a term is going to be 1x, because we need to get back to x to the third power. And our b term here is going to be 4, because 4 to the third power is 64. So we've got our a, we've got our b. Let's substitute everything in. So we get x plus 4 is our first term, and our second term here is going to be a squared, which is x squared. A times b is x times 4, which is 4x. So remember, here's where the minus comes in, minus 4x. And our b squared, our b value is 4, so b squared is going to get us 16. Now, the directions say to factor the polynomial completely. If we look at our first term here, we have x plus 4. That's factored completely. Can we factor x squared minus 4x plus 16? We cannot. This term is not factorable, so this is going to be our final answer. This is completely factored. So moving on to b here, we have 16z to the 5th minus 250z squared. Now, if we take a look at this problem first, before we start identifying whether or not we have perfect cubes, if we look at each term, we notice that there's a common monomial in both of these terms. So before we identify our a and b values, let's factor out what we can out of both of these terms. What do both of these terms have in common? 16 and 250 are both divisible by 2, and we have a z squared in the second term and a z to the 5th in the first term. So we can definitely factor out a 2 and a z squared out of both of these terms. Now inside the parentheses, that leaves us with an 8z to the third power minus 125. Now inside the parentheses here, we have 8x to the third power, so that looks like it could be a perfect cube. We have x cubed. What number raised to the third power gets us 8? So that's a 2. And is 125 a perfect cube? It is. 5 raised to the third power gets us 125. So in this case, our values for a and b, a is going to be 2x, because 2x raised to the third power will get us back to our 8x cubed. And our b value is going to be 5, because 5 to the third power will get us back to 125. Those are our values. We apply our difference of two cubes formula now. So this is a minus b. Remember, for difference, the minus comes in the first term. And in our second term here, we have a squared plus ab plus b squared. So for difference, again, everything in the second term here is all positive. but in the first term we have a negative sign, a minus b. Press pause quick, substitute these values in, and see what you get. So here's this polynomial equation factored all the way down. Now notice here that the 2z out front here traveled all the way down along to our final answer here. So when we have 8x cubed minus 125 and we apply the difference of two cubes formula here, that gets us our second half of the answer in the parentheses here. But we cannot forget that we have this term out front that comes along for the ride. So here's a couple problems for you guys to try on your own. Remember these few key steps here. So for the first thing you should do is check to see if you can factor out a common monomial first before you do anything. Remember, the goal here to apply the sum or difference of cubes formulas is to make sure that our first term is raised to the third power, because we're looking for perfect cubes, which is number 2. After we do that, we need to look for perfect cubes. And lastly, once we have everything factored down nicely, we need to identify our a and our b values and just substitute those right into the formula depending on whether it is a sum or a difference. So depending on whether it's a plus or minus in between the two terms, that will designate which formula you're going to use. Good luck.